Good afternoon, guys. Welcome to the new video. So today we're gonna discuss about IP addresses. So IP addresses is having two version 4 and version 6. Version 4 will discuss now, and version 6 will discuss later on. So as I said in my previous video, IP address, it's a logical address which can assign to the LAN card of our devices to identify a particular device. Okay, so before assigning IP address to the devices, you have to take care certain rules. So now we discuss that rules. There are 10 rules to configure an IP addresses. So first rule. So I will write IP version 4 address. It's a logical address which can be assigned to devices. So rules. First rule is it's a 32-bit address, and 32-bit address, and it's divided into 4 octet. It's divided into 4 octet. Okay, so let me draw a line here. You can see, and let me take a eraser and I will cut here, here, and here. So now it's having 4 parts. Each is 8-bit. It's an octet. It contains 4 octet. First octet, second octet, third one, and this one fourth. Each octet is having 8-bit, 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 and 8-bit. So this is the first rule. And minimum value of second rule, just second rule. Minimum value of each octet is minimum value of each octet is 0, and maximum value is 255. So we can see that each octet is having 8-bit. Minimum value means it should be all 8 bits should be 0, right? 4, 5, 6, 7, 8. So we can convert these into decimal. It should be like this: 0, 1, 2, 3, 4, 5, 6, 7. So if you convert this into decimal, it would be like this: 2 raised to 0 into 0 plus 2 raised to 1 into 0 plus 2 raised to 2 into 0 plus etc. up to 2 raised to 7 into 0, which means 0. Minimum value is 0. And the maximum value is 255, which means all our 8 bit should be 1 to get the maximum value, right? 6, 7, 8. So we can convert this into decimal. 2 raised to 1 into 1. 2 raised to 2 into 2. 1. 2 raised to 3 into 1. 2 raised to 4 into 1. 2 raised to 5 into 1. Plus 2 raised to 6 into 1 plus 2 raised to 7 into 1 is equal to 1 plus, I can rewrite here, 1 plus 2 plus 4 plus 8 plus 16. 1 second. 16 plus 32 plus 64 plus 128. It would be 3, 7, 15, 31, 63, 127 plus 128. So maximum value is 255. This is the second rule. Each octet would be, minimum value would be 0 and maximum value will be 255. Okay. Then third rule. IP address can be divided into 5 classes. There are 5 classes of IP address. Third rule is IP address can be divided into 5 classes. Class A range is 0 to 126. Then class B range is 128 to 191. Then class C range would be 192 to 223. Then class D 224 to 239. Then class E, that is 240 to 255. This is the range. This is the third row. And I will show you third row. Then fourth rule. What is fourth rule? First octet of IP address always define the class. First octet of IP address always define the class. So let me show that. First octet of IP address is always define the class. See, take an example. Take 10.0.0.1. It's an IP. This is the first octet. This is second octet, third and fourth. So first one is defining the class, which means this one class A, right? You can see here class A range 0 to 126. So this one is class A. Take another example. 129.1.1.1. This is which class? First octet always define the class. C, class B, right? So this one is class B. Take another example, 192.168.1.1. This is first octet. Define the class. This one would be in class C. See 192 here. So first octet of an IP address is always defining the class. That is the fourth rule. And fifth one. What is fifth one? We can only use class A, class B, and class C IP address. See, fifth rule is we can only use class A, B, and C. D and E we cannot use that. D is using for broadcasting, and E is for D is for multicasting, and E is for research and development. So we can use uh, IP from 0 to 223 range. Class D for multicasting, and class E for research and development. Research and development. Okay. So now we go to next rule, which is each and every class having unique subnet mask. See, by default, each class is having a subnet mask, which will be a unique. I'll show you that. Sixth point. Class A. Subnet mask of class A is 255.0.0.0. Class B subnet mask is 255.25.0.0. Sorry. Class C subnet mask is 255.255.255.0. Class D and E, it's not applicable. And class E, it's also N. Then we can go to seventh rule. So let me show that. Seventh rule is, before that, I just want to explain about subnet mask. See, subnet mask divides the IP address into two parts. One is network part and other is host part. For example, subnet mask divides IP address into two parts. One is network ID, other is host ID. Take an example I took, which means subnet mask, you can see 255 and 0, right? See, 255 is there, 0 is there. So 255 represent network part and 0 represent the host part. Take an example. Take class AIP 10.0.0.0. 0.0.1. It's a class A IP, and default subnet mask for this is 0. So 255 represent the network part. This is 255. This one is network part, and 0 represent the host ID. So this is network ID. This one is host ID. Okay. So take another example. 172.16.0.1. So default subnet mask for this is 0.0, which means this is the network part and this one is host part. Network, host. Okay. If you take class C address, I'll show you that 192.168.1.1 and subnet mask is 255.0. So this one network part, host part. This would be the network and this would be the host part. So I hope you guys got it. Then to create a network ID should be always same and host ID should be different, unique. So I'll clear that point. Just 8th rule, right? So suppose we have multiple PC connected to a search and each is having IP of 10.1.1.1, this one 10.1.1.2, this one 10.1.1.3. It's a class A IP, right? So see, network part is class A. 255 represent the network part, right? We already discussed that. So 255, it's first octet, represent the class. This one is class A. So see, network part is same in all IP address, but host part is different. To create a network part should be same and host part should be different. And 8th point, that is how to define an IP address. So I can write here 8th point. How to define the IP address. How to define the IP address. See, class A and class B and class C, we can use that. I already said that. And class D and E, we cannot use it. And from class A to class C, it will be 0 to 223. But 0 also we cannot assign because it's not valid. So it would be 1 to 223. If you can, I will show you that ncpa.cpl. I will try to assign IP. See, 0 is not valid. Please specify a value between 1 and 223. So we cannot specify or we cannot give 0 as an IP address. So, and up to 223. And last IP is, check the last IP also. Try to give 223. It would be a broadcast IP. So it will not take. I will show you that. If you type here, see. It's also invalid because it's a last IP and it will be a broadcast IP. And here, this is first octet. First octet. Second would be 0 to 255. Third, 0 to 255. And fourth, also 0 to 255. So the first IP would be, it would be like 0.0.0 to maximum 223.255.255.255. This is not valid, so we cannot assign this IP, and this one also we cannot assign to the devices because it's a broadcast IP. Okay, of 223 network. So let me explain you ninth rule. Ninth rule. What is ninth rule? It's maximum number of IP address in one network of any class. So in class C, how many IP we will get? Class C. Class C. Take a class C IP 192.168.1.0 up to 192.168.1.255 we can give, right? So maximum IP address is maximum IP is 256 minus 2. First IP would be the network IP and last one would be broadcast. So total available IP address is 254 in class C. Class B, it would be 172.16.0.0 to 172.16.0.255. Then come to 1.255. Then up to 16.255.255. Maximum IP in this class B is 256 into 256 because changes are happening in two places, right? Here and here. Minus 2. How much it would be? Take the calculator. 256 into 256 would be 65536. 65536 minus 2. That is 65534. So in class A also you will get class A. 10 dot take a range 0.0 to 10.0.0.255 to, then changes would come in next place. It will be once it reaches like this, then again it will go, then finally it will reach to like this. So changes are there in three places. So total IP would be 256 into 256 into 256 minus 2. So it would be into 256. This much. 167, sorry, 167 77216 77216 minus 2. Answer would be 167 77214. This much IP we can use in class A. And the last rule is there are two type of IP. IP address can be divided into private and public. So private, we can use it as a free It's a freeware, and we can use this IP in our local area network. In our LAN side, we can use this IP, which means we have a LAN network here. And it is connected to a centralized device switch. So it's a LAN. We can use this private IP in this network. But see, outside, if outside user is try to connect to this PC, it's not possible. We cannot access private IP from outside of our network, LAN network. But public IP we can access from WAN side also, and we can use this IP in WAN side as a public. I'm talking about public. You can see here. It's a paid. We can use this in WAN side. We can access IP also anywhere through internet. But private IP we cannot access through internet. It's a free one. It's a freeware, and we can use this in our LAN network only. And it's non-routable, which means we cannot see this private IP in ISP, Internet Service Provider routing table. But public IP, it's routable. We can see this IP in ISP side. Okay. So I hope you guys got it. So thanks for watching. Bye bye.